Hello, my name is Andriy Khizhniak. I'm a PhD student and senior lecturer from Ukraine. Today I will present you domain-specific language for describing personalized practical tasks in IT education. The importance of practical-oriented learning has grown significantly in higher education, particularly in the training of specialists in IT fields. Recent academic literature research increasingly emphasizes the use of formal models to describe learning processes. The formal representation of tasks' internal structure is crucial. Tasks should be well structured, machine-readable, and parameterized. Achieving such a balance can be facilitated through the use of domain-specific language, which simplifies the development of structural components and enables subject matter experts to actively contribute to the education content creation. Attempts to apply the DSL in educational context have been documented over recent years. However, the development of specialized languages for generation and assessment of practical tasks remains unexplored. Existing solutions have common limitations such as very narrow specialization or dependence on a specific platform, insufficient support for formal description of verification logic, focus mainly on the micro level, courses and resources, rather than the micro level like structure and content of tasks, a lack of mechanism for adaptation to the description of practical tasks. In view of this, is very promising to create a domain-specific language that will provide the lecturers, teachers, and other staff with formal and flexible tool for creating personalized practical tasks, support controlled task generation and deployment for training. So, the aim of this paper is to present the development of a novel domain-specific language, learning task definition language, LTDL, along with its graphical representation and tools for visually editing source files. We studied approach to the development of formalized description languages, theoretical generalization, analysis, mathematical statistics, and expert research. The domain of proposed DSL is development, personalization, and automated verification of practical tasks in digital learning environments. Target audience is educators and instructional designers who may not be programmers but want to rapidly create interactive practical assignments. On this AR diagram we can see the entities of this domain. So, to create task, you need to understand what the goal of the task is and what objective needs to be achieved. For example, a specific state of learning environment or object which existence can be verified later. Simple example. In order to learn how to create directories in Unix, students must create a directory in a practical task. It's possible that more than one stage is required to achieve the overall goal of practical task. Stage may be depend on each other. The sequence of dependent stages should be grouped into a separate entity, a track. Personalization allows you to automatically generate different versions of the same task by changing certain elements of it. So you need to select the paths that need to be randomized for each stage, variable names, file directory names, usernames, etc. So for each student, unique task will be generated, but its didactic complexity will not differ from the complexity of other student tasks. We will call such paths parameterized variables. An important part of task is meta information, which can be used outside the task itself to understand to whom and when the task can be assigned or how much time it should take to complete it. To complete a practical task, it's usually necessary to deploy a separate learning environment. For the description of the formal grammar of the LTDL language, the BNF notation was chosen. This notation is highly similar to ANTLR4 for grammar format. ANTLR4 tool was used to generate syntax and lexical analyzer and generators. The entity described in ER diagram are present here as graphical representation of language symbols. So the main entity is a task. This initial grammar rule to encapsulate all other entities of our language, such as variable. This is an entity which defines parameterization of a task used in template or in instruction. Variables can exist at the level of entire task, top level, track level, or stage level. Track uses for group stages which depend one on each other. So this represents a linear sequence of steps and consists of variables and stages. Particular stage. It's a single step for entire task. Each stage consists of variables for randomization, preconditions, a list of instructions that must be completed in the learning environment before the task execution begins, checks, so it's some action which should be done in learning environment to check the progress of the task. Such instruction can be like action which should be fired in learning environment. It depends on learning environment type, of course. This definition describes a template provided to the student before beginning task and specified which actions should be performed in a particular stage. Checked, it's a list of instructions. This action is executed upon connection to the learning environment. It depends on the protocol used and learning environment type. Learning environment describes the environment which task should be executed. Included some parameter, instruction for launching, configuration, specific instance of learning environment. Type of relations that establish the nesting of one entity within other, for example, stage being part of track. It's include. Depend, a type of relations that defines the dependency between stages. And use, type of relationship that indicates where parameterized variable will be used. The following tests were created and conducted: parsing test, lexical testing, coded generation testing, syntax tree construction, and identification of unproductive and unreachable symbols. Parsing tests were created for valid construction and incorrect syntax. For lexical tests of grammar tokenization testing, test for special characters, boundary cases, empty files, extra spaces, and the long expression were performed. To simplify perception and cover all aspects of the development personalization practical task, we also propose the possibility of graphical representation of task element. This slide shows how the task is visualized using a graphical version of the language. So we can see two tracks, which each consist of two stages with parameterized variables, definitions, precondition, and checks. All these elements are connected with different types of connections. The new domain-specific language learning tasks definition language, along with graphical representation and tools for visually editing source files, have been developed. A new approach has been proposed to implement the personalized practical task in the teaching of engineering disciplines. LTD is designed as formal specific language for describing the structure of learning tasks independently of subject area, parameterize the tasks, complexity and variability, define rules for automation assessment. Our future work will focus on expanding the system compatibility, namely implementing automated task generation and assessment in the education process for other disciplines, optimize the allocation of university resources, especially servers used for deploying learning environments and necessary for conducting laboratory and practical work, and forecasting their utilization. Development tools for additional monitoring of whether specific students in completed tasks, integration AI for supervision using webcams, etc. Thank you for your attention. Bye bye.